Okay, let's continue with the measurement for the bar reinforcement. First, you have to make sure that you have checked the drawing. Make sure you check the drawing, whether you are given the side view, section view, or whether you are given the layout plan. This one is very important because you need to know how many numbers of the bar available in your drawing. Okay, so the first one, as what I did mention, you can refer to F.8.1 in your SMM. F.8.1 mention the unit of measurement, and also you have to write down based on the diameter, type, and quality. You will always see the word type and quality in your SMM too. So type and quality here are referring to either they are R or T or Y. Remember, Y and T is referring to high tensile, but R is referring to mild steel. Okay. The unit of measurement is in kg, but then you cannot just measure in kg. What you have to do, you have to measure first in meter, then convert to kg. They are conversion table. Then after you measure, then only you have to convert to kg. Okay, this is the example of the layout or from the section view for the correct and incorrect distribution bar. So from this, you can see that the dot dot is the bar that is actually like this. And then if I change the color, you can see that the other bar is like this. Okay, so you can either see from the section view, or either you can see from dot 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 means the bar from the other way around. So what you need to do first, you have to first identify the type of the bar, find the diameter, and find the location. And of course, in this bar reinforcement, you have to measure based on straight and bend bars. There's no curvature. Okay, there's no curvature. We only have straight and bend bars. But then you have to also know what will be the category of the bar. Is it located in the landing slab? Is it in the landing beam? And is it in the staircase? So all these three have to be measured separately. Look at this photo. This is the example of the bar reinforcement inside the staircase together with the bar reinforcement or connected um, with the wall beside the staircase itself. You can see here in vertical and also in horizontal. So this is the bar inside the staircase. This is one of the example. Okay, next one, I would like to recap the formula. In case you are given the length of the bar with the formula, okay, this one is in Malay. So let me change because this is the notes that we have to refer from one of the company. The length is meter, means you only have to measure A. But then if you see this design, this is the bend. Okay, is the standard length, but H is your bend. Okay, either you are given this formula or either you are not be given this formula. Sometimes they give you H as is 2B, is 2C or 2 diameter or 3 diameter, depends. Okay, for the other one, if you have this shape, means you have to add 2H here. So A plus 2H. And if you have number 4 design, this is what you normally seen in the U-shaped bar in your pad footing, for example, or in your pad cap. Okay, you can see the bar is like L shape. Okay, and then this one also something that you have seen before in your pad footing, where you have to measure in meter, 2H plus A as well. Okay, the formula to get the band either being given or either you have to use your scale ruler to measure. So this is part of the recap. In order for you to see in detail, you can also see this one if you are given in detail of H. And in this case, the formula of H is referring to D. D is referring to diameter. So if you see the word 4D, what does it mean? 4 times diameter. Okay, look at this number 1. The first one, H, is the minimum, and then number 2 here is referring to the length of the bar. Okay, so how you want to get the first one? 4D plus 3D and plus 4D plus 3D plus this length. Okay, so the minimum band here is 9D and the total band is 9D plus 3D. This is only one of the example. If you have something like this is normally what you can see in the landing beam, for example. Okay, or maybe you can see this one in the bar reinforcement inside the landing slab connected with the landing beam. So you can see something like this. Okay, so this is 5D, this is how you get 2D, and the length here will be either given in scale, so you have to total up using your scale ruler. Okay, in your drawing, your studio drawing, all you have to use your scale ruler. There is no formula given, so you have to use scale ruler. Okay, another one, this is also the recap session. You can see here the design for number 3 is the maximum of 15D. So all these H have to be total up. What about the last one? The maximum is 9.5D where the minimum is 5D. Okay, so this is to show you that the band formula will be different for different design. I would like to go back to what I did mention earlier, the rule of measurement according to F.8. So unit of measurement is meter, then you have to convert to kg. That means the final unit of measurement is kg. The classification of the bar shall be as follows. So what you have to do, first when you have this category, when you have checked your drawing, you have to first identify the heading. Let's say I have the first one, heading high tensile. So you can write here high tensile. Okay, high tensile bar reinforcement. This one can be written as heading. I put here heading. Why you need to put here as heading? Because maybe you can see more than one numbers of the bar. Okay, or you have another category. We can put here multi-bar as described. You know how to use the word as described? Why we use the word as described? Because we are explaining what is below, or you can say mostly as the following. But the word as described is the common sentence that normally will be used to write down a description in your heading. So once you have the heading, do you need to repeat the sentence? No need. You only have to write once, then make sure the heading will be underlined. Okay, make sure the heading is underlined. Okay, I also would like to highlight these two clauses in your SMM. Can you open your SMM? Open your SMM under clause F.12. Okay, so they are explanation on the horizontal bar and the vertical bar. Okay, your SMM. Sorry, F.8.6 and F.8.7. So if you refer to F.6.8 and F.6.7, F.8.6 and F.8.7, they are explanation on the horizontal bar and vertical bar. Okay, so if you have the vertical bar that is more than 30 degrees from horizontal, you can group together. This is normally happen where you have very long straight run reinforcement bar in the staircase. For example, I think we have one design in China. We have more than 20 numbers of the step. Normal step for one flight is only 20, I think about 10. Sometimes you can see 12. But if you're very long, it means you have very long bar reinforcement. Okay, so if you have the sloping and the horizontal bar that is more than 30 degrees from the horizontal, you can group together. This is in case you have this kind of category. Okay, what I would like to highlight is horizontal bar, and if you have the bar that is sloping 30 degree, you have to group together. Is it vertical, then it is sloping more than 30 degree, also you have to group together. Okay, now if you look at on the right hand side, this is the example of the layout of the bar reinforcement inside the sloping staircase that is also attached inside the landing slab or landing slab, and also the landing beam if possible. Your studio design did not have this connection. Okay, but then they are also designed where you have the landing beam in between the flight. So this is your flight, this is your flight, this is your landing slab, and this is your landing beam. Okay, this is also another design for maybe high tensile or main bar that is interconnected. So what I would like you to understand as well, when you need to measure for the bar inside the inside the staircase, make sure you measure the bar that is also interconnected. Okay, I give you one example. Let me clear the annotation. If you have the bar that is straight like this and then go inside the beam, so are you measuring this one together, or you have to measure or you have to measure this bar separately? The yellow color, can you measure all together even though it go inside the landing beam? Yes or no? Yes, you can measure all together. Make sure you measure the bar that is interconnected with another element together. You remember last time we have the bar reinforcement like this, straight, and then you have like this, and straight, you have like this in your column, stump, and also in your foundation. So you have to measure this and this one together, right? Same goes to the bar reinforcement inside the staircase. If there are bars reinforcement connected from the staircase going inside the landing slab or landing beam, you have to measure together under one item. But then you have to check in the drawing, this one falls under landing slab or landing beam or in the staircase. That is the most important. Okay. Now, I also would like to go to the overview of the bar reinforcement or the layout beam or layout landing slab and staircase that you have seen in the AutoCAD drawing. This is one of the example. This is the example where you have the landing slab. This is the landing slab, and then you have the beam. You have to check whether this beam is under beam or under landing beam. If you have to measure for the staircase, you have to measure the landing beam under the staircase. But beam, you have to measure under the frame. So please check carefully before you start measuring. Okay, next slide highlighted the example of the bar reinforcement available in the staircase. This is what I did mention. So if you look at this, let's say I ask you to measure the bar reinforcement inside the staircase. So how the design would be looks like. One, okay, then I continue here. Sorry, this one, and then here, number two, and this is number three, and then this one is number four. Can you see the straight line? There are four straight line over there. If I draw in a section view, one, two, three, four. Can you see that? This is straight, one, two, three, and four. So what you have to do in your sidecast, you have to label all this. What is the length here? 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 Then total up. That is how you measure the total length for the bar reinforcement. Is it okay? Can you follow? Okay. Now I would like you to look at your drawing. Look at your drawing. Look at your studio drawing. Look at your studio drawing. So what you have to do first, you have to check the scale. Make sure you check the scale. Okay, this is the section detail for the bar reinforcement and section detail of the drawing. Okay, how you want to start measuring? First, you have to identify the bar reinforcement in the landing slab that having similar specification in drawing number 2. Okay, number 2, you have to identify the bars that are not belong to landing slab. Then the bars that is not belong to landing slab will be the bars inside the staircase. Is it okay? This is the first step. Okay, after that, after you identify this bar, you have to check what would be the specification of the drawing, what would be the specification of the bar reinforcement. For example, let's say I zoom in. You can see here, this dotted line, this is Y10. And the second one is Y12. Can you combine? Can you combine Y10 and Y12? Cannot, because the bar reinforcement having different diameter. Even though both are high tensile, but different diameter must be measured separately. Okay, look at the bottom. Y12, 150. This is R12. Can you combine these two together? Cannot. But if I highlight, Y12 at the top flight and Y12 at the bottom flight can be total up. You can combine under one item. So logically, when we look at this drawing, okay, let's say I would like you to identify how many items to be measured. How many items to be measured? We highlight one by one, yeah? Okay, this is number 1, Y10. So you can see that there is only one specification of Y10. So this is one item. Next one, let's say we change the color to red. So you can see here Y12, 150. This one also Y12 to 150. So can you combine? Can. Okay, next one, a different color. Let's say I have pink color, so you can see here R12 250. This is R12. So this R12 has to be measured separately inside the staircase. Okay, but if you look at the red color, for example, the red color at the top flight is the bar reinforcement at the straight flight. Sorry, the bar reinforcement that is straight line like this. So let's say this is the bar. So 1 and 2. Okay, so another one is 1 and 2. This is inside the staircase. Okay, for the staircase you can see clearly this one, also the bar reinforcement. So this one actually you can continue to see the highlights. So what about the yellow color? For this one, the yellow color is the dot, 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 dot. So in order for you to know how many numbers of the bar for this dot, 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 you have to measure by looking at the width of the staircase. Then only you can divide with how many numbers. Okay? Now, I would like to go to drawing number 2 in this staircase. Okay, if you look at this drawing number 2, okay, can you see the detail of the landing slab? Okay, can everyone open your drawing? Look at the detail of the landing slab. Drawing number 2 refer to landing slab. Can you use your highlighter to highlight which one is Y12 150, which one is Y12 250? Okay, I stop here for a while.